Our advanced topics in biology course is right now split into sort of two halves. Half is taught by myself and the other half is taught by Dr. Myers. And Dr. Myers' half focuses on what we call biotechnology. So really research methods in biology and the skills that students might encounter in labs in college and potentially beyond if they pursue graduate studies. So his half is really lab hands-on based. My half is focused on my specialty, which is immunology and microbiology. So students in our AT Bio course are getting exposure to sort of all the basic concepts of immunology. So that includes different cell types. You know, everyone sort of has some idea that we have white blood cells, but AT Bio students now know all the different varieties of cells that make up that group. They understand how they work in different scenarios. They even have some understanding of what can go wrong, things like autoimmune disorders, allergies, that sort of thing. So in the context of that, our students learn about B cells, which are the specific cells that make antibodies. And most people have at least heard of antibodies. You know that you have antibodies against a disease that you may have had or exposed to. We're hearing right now a lot in the news about antibody tests for COVID. So the project feels more relevant than ever, maybe. So one of the things that's really interesting in medicine right now is we are starting to use antibodies that are produced outside of people, so in a lab, to treat different things. So for example, if you hear in a commercial on TV a drug that ends in mab, so for example adalimumab, that mab ending actually stands for monoclonal antibody. And so what I challenged my AT Bio students to do is they had to come up with some novel application. So the scope was very wide. It simply had to be something new, a novel application for monoclonal antibodies. And so they could take it lots of directions. They could treat a disease. They could make a new use for an antibody in research. So they got to really bring in a lot of choice to the project. They really got to pursue what they were interested in. And so what I end up with are these amazing, creative, scientific ideas from students that really have become super knowledgeable. They're using primary literature, lots of different sources to build their idea and decide if it's feasible. And what they're really doing in this project is the sort of the ideating stage. They aren't actually then going to a lab to produce these things. That's probably a PhD worth of work, not a Derryfield diploma, unfortunately. So they are creating these incredible ideas. And then as the culminating sort of deliverable on that project, they're presenting a scientific presentation. And when they present that, they're presenting it to their peers, so the other students in the class. They're obviously presenting it to me. I often get some faculty guests. So Dr. Carter was able to attend in the fall. We've had a few other teachers come and join in to listen to these presentations. But most importantly, I'm able to get some of my very good friends from my PhD work who are willing to come and spend the time listening to these students' presentations. And these are people with PhDs working in research, working in labs, who spend their time really sort of giving feedback to our students, asking questions. And so what we're going to see here is sort of what came just after Erica's presentation, sort of her interaction with these experts. So before I show the video, I'd love Erica to describe her project a little bit and sort of what the idea was behind your work.
Of course. So I started this project not feeling very well equipped with the knowledge that Dr. Moon had already provided for us, but not really sure where I wanted to take it due to the open nature of the project and us really being able to choose whatever we wanted to do with it. I decided eventually to go with bone metastasized breast cancer, finding a treatment for that using monoclonal antibodies. And this was after reading that this type of cancer is fatal for about 73% of the women who are diagnosed with it. Using the knowledge that I had already learned about monoclonal antibodies, as well as the general knowledge that we had accumulated over the course, I was able to research and find key proteins and binding receptors that signal growth and spreading of this cancer, or the metastasis element. And then my treatment was to develop essentially a block of that signaling, which would halt further spreading of the cancer or the metastasis. And then through both peer feedback and guidance from Dr. Moon, I was able to polish this project and present it with a high level of understanding.
Awesome. Thanks, Erica. So now I'm going to share with everyone the interaction that Erica had with two of the what we call experts in our audience. The first is Michael Breen. You'll see him on screen first. He is a Ph.D. student in biomedical sciences at Johns Hopkins University. And then the second person you will see other than Erica is Dr. Tony D. Piazza. He is a researcher at the NIH. His specialty is actually antibodies to viruses. His work right now is centered around developing antibody treatments and vaccines for COVID. So he's actually part of the team working on that research.
Do you know if there is increased level of this receptor on cancer cells compared to neutrophils? Because if there is, maybe the worry of eliminating the impacting the neutrophils would be lessened if there's just way more receptor on the cancer cells.
Right. Okay. Yes, I think there is more of, from my research, there's more of the CXCR2 receptor on cancer cells because that's actually the growth checkpoint.
Right.
So I think this is a very minimal concern with the neutrophils. Essentially, that's just worst case scenario if it ends up blocking few, but it wouldn't be a major problem for the neutrophils. I don't think it would completely block all of them.
Great, thank you.
I had a quick comment, sort of getting along the same lines with off-target effects of this treatment on neutrophils and how you might be able to increase antibody specificity to the cancer cells. So there's some interesting tricks you can do with protein antibodies where you can make them bispecific. So rather than them just being specific for this chemokine receptor, you can actually make another antigen binding fragment on that molecule. And if you have any tumor specific antigens, so things that are uniquely expressed or things, as Michael was saying, are highly upregulated on those cancer cells, you could try to actually make a bispecific monoclonal antibody to try to increase targeting to the cancer cells, as well as at the same time blocking that receptor so that the cells that are targeted aren't going to be able to proliferate or grow as well with your CXCR2 neutralizing effect.
Right. That's a great thought. Thank you. I definitely think that there's a lot of places where it's especially prominent in cancer cells, and it needs to be researched on certain cancer cells because it really does vary within those and changes a lot between those different cancer cells.
So that was pretty impressive. That's the second time I've seen it. I think I understand it better this time, but I am very impressed with you, Erica. That's for sure. That's for sure. So Erica, let me just start out with a couple questions for you. Can you tell us a little bit about what Derryfield courses you've taken? You're now a senior. What courses prepared you for this course?
Yeah, definitely. So throughout my time at Derryfield, I've gone to Derryfield since 6th grade. And I've been really involved in classes and interested in classes in the arts, the humanities, and the sciences. And then my passion really started to develop towards STEM-focused classes in my junior and senior year at Derryfield. And then signing up for courses for my senior year, I knew I wanted to challenge myself with AT biology. So I felt that one class that really prepared me for that was in my junior year taking honors physics with Mr. Cousino. Not only did this make me realize the passion I had for both math and science, but it also taught me that asking questions for understanding is really beneficial in helping grow that understanding, and is very important in new and unfamiliar classes, such as taking a class such as AP Bio. And I really knew that even if this class got challenging, I felt more well equipped for classes such as this.
And can you tell us a little bit about your favorite aspects of this course?
Yes, of course. So I really liked that AT Bio was very unique this year. As Dr. Moon mentioned, half of the year was split between Dr. Myers teaching us more about biotechnology and lab skills, and half of the year was focused on immunology with Dr. Moon and this big project. This variety throughout the year really helped me and was one of my favorite aspects, because I could learn about the different applications of biology from two different experts in the field. And biology is such a broad topic that was really interesting to have these different activities and hands-on learning experiences that helped to further my understanding, from both the hands-on labs to this big end of the year independent project. I really felt like I got a variety of different learning experiences from those two courses.
Do you think this experience has prepared you for future research, especially that might happen in the real world?
Of course. So for me in particular, I'm going to be studying bioengineering in college. So I will definitely have a lot of research within that in both college and in my future career. So this project really prepared me for that, but it also helps in so many different fields, because one thing that I really appreciated was Dr. Moon taking the time before the project to explain to us how to look for key details within large lab reports that can sometimes seem overwhelming. And that really helped me within this research and kind of helped me overall to strengthen that skill of looking for really important details within a large document or a large text that can seem overwhelming at first.
What a terrific and important skill.
Yes, definitely
For sure.
research.
Can you tell us how your experience in the class changed when the class went all online?
Of course. So learning online was something huge to adapt to, but teachers, all of my Derryfield teachers were very helpful in assisting this change, and they were always willing to help. For AT biology in particular, because of this project we were working on, a large part of it was independent work. However, Dr. Moon was always there to help and answer questions. And it really taught us, just being isolated, how to really use our time well, take on the responsibility of doing all this independent work, and also how to persevere through this remote learning. But it was really helpful to be working on this project, and the independent aspect of it really was almost enhanced by this. So it was pretty helpful, actually.
Taylor, I have a couple questions for you. First, this is a brand new course. It was invented by you and Andy Myers to replace AP biology. Can you talk about the difference between teaching AP and teaching advanced topics?
Yeah, so the best thing I can say is this course could not have diverged from AP biology more. The only similarity is that they are advanced and that they're about biology. So this course is really more material that students would find in a 200 or 300 level biology elective course in college. AP biology really covers the same topics that our biology and honors biology classes that many ninth graders take. It was really that same material, but with maybe some harder questions and a little bit more coverage of some topics. This course is now so focused on skills. So the lab skills, the skills that go with sort of this project. There's some content for sure, you know, an understanding of cell biology, and in my part of the course, an understanding of basic immunology. But it is now so much more about the skills the students have, and it really is far more advanced than the AP biology class was.
Isn't that wonderful? Well, you're talking about skills. Can you talk about cross-curricular skills that appear in this course?
Definitely. So certainly written communication, I think, is a huge part of any science class. I mean, we have sort of strayed from true formal lab reports, but being able to write and describe what you did and describe what you found is still a critical skill in all sciences, and students definitely get to practice that in this course. But particularly with this project, as you can imagine from needing to give a presentation to a panel of experts, this particular project really highlights students' oral communication skills. And one of the things that was really important to me in building that skill in this class was that students had time to get feedback. So before they arrive at that sort of culminating presentation, they've already had feedback from me on their presentation as well as their peers. And that means they've also given feedback. And I think the ability to watch a presentation or read something and give critical but kind feedback is such an important skill moving forward in students' careers. And I don't know that everyone gets enough chances to practice it. So I wanted to make sure I built that in. Additionally, what you don't see as a part of this video is students actually produce two final parts to this project. They produced this scientific presentation, which they delivered via Google Meet. And then they also produced what we called a sales pitch. So that could be a presentation or a written document that the way I described it is it had to stand alone. The students weren't going to present that work. They were just going to turn it in. And then that work actually went to a group of financial minded people in their financial careers. And they sort of Shark Tank style read those proposals and decided which one they felt was most fundable. So that was really a challenge to these students who now had such an incredible amount of knowledge and such a depth of knowledge on immunology to then sort of backtrack out of all of that vocabulary and build a document that someone who had no immunology knowledge could understand and like enough to say, you're the winner and you get funded. So I thought that was a really cool, important skill as well. I think a lot of scientists, even I would argue some of the best scientists, are not very good at talking to the, public about their work.
What a fabulous example of a project that has a real world application dimension, where you've got actually two real world scenarios. One where you've got to stand up to scientists, and then the other where you have to stand up to finance people and make the case for funding. Really great construct. Can you tell us a little bit about those scientific experts? Where did you find them, Taylor? Who are these people, and why were they inspired to help?
Yeah, absolutely. So I am drawing from my connections from grad school. So I did my Ph.D. at the University of Rochester in their School of Medicine. And I made incredible friends there, as well as incredible career networks. And that's really what I'm utilizing here is, I put a call out at the beginning of this year and I said, here's the project I've designed. Is anyone willing to help? And this group, actually both in the fall and in the spring, came through for me. And what's important to me is that I get experts who I know will think critically about every project and give kind feedback. And for better or worse, not every PhD falls into that category. So they are carefully chosen for sure. But these are some of my close friends. Like I said, you know, they're at Johns Hopkins, they're at the NIH. They themselves are doing incredible work. And I think it's important for our students to see that career path exists, and to meet those people. And if one of these Derryfield students came back to me in, you know, 6 to 10 years with a PhD and said, I'm looking for a job, that guy that listened to my presentation, what's he doing now? Like, I think we're growing their network along with utilizing my own.
I think so too. I think Erica is lucky to have a teacher like you too, Taylor.
Thank you.
Erica, what's something that you like about having Dr. Moon for a teacher that may have nothing to do with biology?
Oh my goodness, so many things. Biology was definitely one of my favorite classes this year. It's so fun because not only is she a great teacher, but it was just a very welcoming environment. I think also having only about 10 to 12 kids in our class, it was so great because it was a really close environment. I don't know if Dr. Moon mentioned this already, but we had just very good like teacher-student relationships where we all felt comfortable asking questions and kind of discussing as a group. That was a really good environment to be in, especially in such a challenging class.
Oh, that's wonderful. And I think Dr. Moon must feel very satisfied to hear you say bioengineering major.
Absolutely. We have one whose passion pursuit is science.
We like to hear that. We like to hear that, right?
Definitely.
Fantastic. Thank you. Thank you both so much for coming tonight. I so appreciate it.
Thank you for having us.
Thank you so much.
Bye-bye.